Hi everyone, in this video we're going to go through determining the gradient and the intercepts. So we've already covered the formula y equals mx plus c, and we know that m is the gradient and c is the y-intercept. But there's other ways of finding the gradient and also ways of finding both your x and your y-intercept. So first of all, we're going to go through determining the gradient. So let me just get my highlighter. I might change from green to yellow just so we can see it a bit easier. So your gradient is basically how far up we go. So our rise, so you can see here, your rise over how far across we go, your run. All right, that's all it is, your rise over your run. And you can have a positive gradient. So if your rise is positive, okay, you're going to have a positive gradient. So kind of think about it climbing up a hill. All right, we're going to be positive, but if we're going down, your rise is negative, okay? So it means that our gradient is going to be a negative number, but your run is always going to be positive because we always go in the positive direction. Let me just change this quickly. So we always go in the positive direction, you can see there, but we can either go up or we can go down if it's a negative gradient. Now, the formula you use is this one here. So that's what we're going to look at today. So you've got 2 points and it's a straight line. So we just need to use 2 points on the line to determine the gradient. They can be any 2 points you like. All right. Try to choose, if you had to choose points with whole numbers. They're just easier, and positive numbers are easier. But you can use this rule for any 2 points on the graph, on the line. All right, so there's quite a few questions here, and I'm not going to do every single one. So I might just do the left-hand side and leave you to do the right-hand side. So let's have a look at question A first. All right, so I've got the points 2, 4 and the point 5, 6. All right, so what I always do, because you're using a formula, just identify x1, y1, because remember, this is our formula. Let me just circle it. This is our formula here. So we need to do y2, y1, x2, x1. All right, so you got first point. This is your x coordinate. This is your y coordinate. Because it's our first point, we're going to call it x1 and y1. This is our second point. So remember, your coordinates are x, y, but because it's my second point, I'm going to call it x2, y2. All right, so first of all, just labeling them, x1, y1, x2, y2. And then we use our formula. So I'm going to write this in blue. So m being the letter we use for gradient, y2 minus y1. And basically, that's just the difference in your y coordinates, how far up or down we've gone over how far across we've gone. So x2 minus x1. All right, so when we're substituting in, I write y2 first. So in this case, it's 6. y1 is 4, so minus 4. And then x2 is 5 and x1 is 2. All right, so do you see where everything has come from? So the y2 is 6, y1 is 4. So I've got 6 minus 4 on the top, and then on the bottom, x2 minus x1, so 5 minus 2. And then we just go ahead and do that. So 6 minus 4 is 2, and 5 minus 2 is 3. So our gradient is 2/3. That just means we've gone up 2 and across 3. That's all it means. Rise and run. All right, let's have a look at, actually, I'm not going to have time to do all of them. So let's skip C and move on to E. Now, this is from your textbook. I think it was question 8 from memory. So question 8. Actually, I'll just pause. All right, question 8 from 3D. So you can go back and check your answers there because I'm not going to do every single question. All right, -2 and 5. And then the other point is 3, 7. All right, so labeling them first. All right, so remember this is our first point. The coordinates are x, y, so it's x1, y1. And the coordinates of the next point, x, y, because it's the second point, we're going to write x2, y2. All right, so I'm going to write the formula. Let me just get this ready. Now, it's a good habit to get into, writing the formula every time, and then it'll just stick in your mind. Okay. All right, so substituting in. So y2 is 7, y1 is 5, x2 is 3, x1 is 5. Oh, no, it's not, it's 2. Sorry. So x1 is -2. All right, just might double check that I've got that right. So 7 minus 5, 3 minus -2. So just be careful with those negatives. All right, so we've got 2 on the top and then 3 minus -2. So when you've got two negatives together, it becomes a positive. So it's going to be 2 over 5. So basically what this means is we've gone up 2 this time and across 5. So just think about your 2 points. We've started here and gone to here. All right, and then your straight lines going in between them. All right, so we've gone up 2, across 5. And you can kind of see that if we've gone from 5 to 7, 5 to 7 is 2, and then from -2 to 3, difference is 5. All right, let's do one more. I might do K. I think I've only got room on the page for one more anyway. So what have we got? -5, -6, and -4, -8. All right, so labeling them first. Now, if you follow my steps, you won't make any errors. It's all routine stuff. All right, there's no problem solving. You're just using a formula. So you're labeling the points and then putting it into the formula. All right, so if you miss any steps because you get lazy, that's when you make mistakes. All right, so just copying everything I do. All right. All right, y2 is -8, y1 is -6, so it's -8 minus -6. All right, so don't forget that minus in the rule, and then there's a -6 there. x2 is -4, then we've got minus -5. Remember, when you got two negatives next to each other, they become a positive. All right, so we're going to have -8 plus 6 over -4 plus 5. Now, if you get stuck with your negatives, although you should know your negatives, but if not, double check on your calculator. So -8 plus 6 gives me -2, and -4 plus 5 gives me 1. All right, so obviously we would write that as just -2. But if we leave it as a fraction, you can actually see what is happening with your gradient. So we're actually this time going down 2, so going -2. So there's our original point, and we're going across 1. So if I was to draw a line going through them, you can see it's a negative gradient. So down 2, across 1. All right, so have a go at doing some more of them. Remember, it's question 8 from 3D, so you can go ahead and check your answers. All right, so the second part we're going to go through today is the intercepts. So the intercepts are another important thing with a straight line. We've already covered y-intercepts, so that's where the graph crosses the y-axis. Okay, so you can see here, your y-intercept crosses your y-axis. Your x-intercept crosses your x-axis. Now, the good thing about it is it's not too hard to calculate. So if we're calculating the x-intercept, all we do is let y equal 0. And when we're calculating the y-intercept, we let x equal 0. All right, so let's go ahead and do that. So let's do question A. Now I always write, and remember what I said before, following these steps will help you remember and also make sure that you don't make any little mistakes. So your x-intercept, we let y equal 0. So our expression, sorry, not our expression, our equation for question A is 4x plus y equals 4. Now, if I'm finding the x-intercept, I'm letting y equal 0. So wherever I've got y, which is here, I'm now writing 0. So we've got 4x plus 0 equals 4, and then I'm just solving for x. So this is where a little bit of algebra comes in. So 4x equals 4. This is 4 times x, so the opposite of multiplying by 4 is dividing by 4. So your x-intercept is at 1. All right, so if we're writing that as a set of coordinates, x equals 1, y equals 0, because remember I let y equal 0. All right, if I'm finding the y-intercept now, I got to let x equal 0. Now it's a bit different to before. Remember, not in this video, but in previous lessons when we could easily see what the y-intercept was, because it would always be our constant. But that would only be when our equation is in the form y equals mx plus c. So for these, they're not. I've got 4x plus y equals 4. So you could rearrange the equation to get it into the form y equals mx plus c, or you can say, well, we're going to let x equal 0. So here's my x, I'm going to let that equal 0. So that means it's 4 times 0, not 40, 4 times 0 plus y equals 4. Now 4 times 0, anything multiplied by 0 is just 0, so I'm left with y equals 4. So your coordinates, remember we always write the x first. So x is equal to 0 for your y-intercept, and y is equal to 4. All right, let's have a go at doing another one. Now I'm not going to do an easy one. Let's choose a harder one. Let's do J. And I'm going to have to write it down. We've got 6x plus 5y equals 30. Now this question is taken from your textbook too, so I'll figure out which question it was and let you know so you can have a go. All right, so if we're finding the x-intercept, let y equal 0. So I've got 6x, and you'll notice that the y term just disappears because we're going to have 5 times 0. All right, so 5 times 0 is just 0, so we're left with 6x equals 30. So 6 times x, the opposite is dividing. So they cancel out, and x is equal to 30 divided by 6, which is 5. So your coordinates are 5, 0. Let's find the y-intercept by letting x equal 0. So we're going to have 6 times 0 this time because x is equal to 0 plus 5y equals 30. So that goes because anything multiplied by 0 is just 0, and we're left with 5y equals 30. Get y by itself, divide both sides by 5. So y is equal to 30 divided by 5, which is 6. And if we're writing that as a set of coordinates, remember you write your x first. So y-intercept x is 0. So we've got 0, 6 is our coordinates there. All right, so have a go at doing some of them on your own. All right, so just look at what I've done. All right, and then if you have any questions, you can ask me. All right, bye. Actually, sorry, before I do go, I just realized I was going to see which question it was, so just bear with me. All right, so this question here is question 4 from 3F. So you can go and have a look at the answers once you've done the questions. All right, bye.